All right, and our final problem for today is again balancing redox reactions using a half reaction method. We're going to take a look though at a reaction that's in a basic solution. And the process is very similar. First thing you want to do is identify what's being oxidized, what's being reduced, so you can write your half reactions. As you take a look here, be careful. This is hydrogen peroxide. It's one of the few instances in which you'll see an oxidation state of oxygen that is different from -2. In this case, it's -1. And the hydrogen is going to be +1. As you take a quick look at our Cl2O7, here the oxygen is going to have that -2 oxidation state as it normally does, which means that our chlorine atom is going to have a charge of, or an oxidation state of +7. As you take a look at the product side here, again, oxygen is going to have a charge of -2, or an oxidation state of -2, and then the oxidation state of chlorine here is going to be +3. And then the oxygen here is going to have an oxidation state of 0 because it's in its elemental form. As we try and identify what's being oxidized, what's being reduced, our oxygen goes from a -1 to a 0. So here the oxygen has lost electrons and is therefore being oxidized. As you take a look then at our chlorine, it goes from a +7 to a +3, indicating it's gained electrons and will therefore represent our reduction half reaction. So as we split this up into two half reactions, we'll put the oxidation over here again and reduction over on your right. Step one was just to identify those two half reactions, and we decided the oxidation half reaction was the H2O2, and the reduction half reaction is going to be our Cl2O7, forming that ClO2 minus. So we've got our two half reactions here. Step two is going to be to balance any atom that's not oxygen or hydrogen. As you take a look, we only have oxygen and hydrogen in the oxidation half reaction, so that's easy enough. As we look at the reduction half reaction though, we are going to need to balance out our number of chlorines. We've got 2 on the left, and so we need to get 2 on the right there. Step 3, got to take care of those pesky hydrogen and oxygen, and we are in a basic solution. However, we're going to start out very similar to what we did in acidic solution. The very first thing we're going to do is we're going to balance out the hydrogen here by adding hydrogen ions, H2O2, O2 plus 2 hydrogen ions. But then you have to remember that we're in a basic solution, so we're not going to have a whole bunch of these free hydrogen ions floating around. And so however many hydrogen ions you add, you want to add the same number of hydroxide ions. And however many hydroxide ions you add to that side that has the hydrogen ion, you want to add that same number to the other side of the reaction. And once you do that, you can then rewrite the equation and combine your hydrogen ion and hydroxide ions to form water. And so it's really just a trick to help you get the half reaction balanced. And you ultimately want to recognize that because you're in a basic solution, you want to have those hydroxide ions as opposed to those hydrogen ions. All right, and so as you take a look at the reduction half reaction, you should notice that we don't have any hydrogen to balance. We have the oxygen. And so we can balance out the oxygen by adding those hydroxide ions. And we're going to need to add, let's see, we've got 7 on the left. Oh, what? We've got 7 on the left, and we've got 4 oxygen on the right. And so we're going to add 3 hydroxide ions to balance out the number of oxygen. Now hydrogen is a player, and so we're going to balance out the hydrogen by adding those 3 hydrogen ions on the other side of the reaction. But then remember, because we're in a basic solution, we're going to add however many hydroxides as hydrogen ions, and we have to add that same number to the other side. And then we'll sort of simplify this. We've got 3 waters plus our Cl2O7. And then on the right-hand side of the reaction, we got 2 ClO2 minus and 6 hydroxide ions. Whew. Okay, so once we've gotten the half reactions balanced for atoms, we then want to balance them for charge, which is our next step, step number 4. As you take a look at the oxidation half reaction, we've got charge of -2 on the left-hand side and a 0 charge on the right-hand side. So to balance out the charge simply by using electrons, we need to add 2 electrons. To the right-hand side of the equation, so now each side has a total charge of -2. And again, that makes sense because we're doing oxidation, we should be losing electrons. As you take a look at the reduction reaction, we've got on the right-hand side, on the left-hand side, a total charge of 0. On the right-hand side, we've got a charge of 2 negatives here and 6 negatives here for a total charge of -8. So we're going to have to add 8 electrons on the left-hand side. 2O plus Cl2O7 forms 2 ClO2 minus plus 6OH minus. So that's step 4. Step 5 is where you have to watch out. Maybe you have to give a multiplier here because you can't gain any more electrons than you lose. Or moles of electrons. And so as you look at this, we're losing 2 electrons, but somehow gaining 8, which means we have to multiply our oxidation half reaction by 4 to give us 8 hydroxide plus 4 hydrogen peroxide, 4 oxygen, 8 waters, and 8 electrons to match the number of electrons gained in the reduction half reaction. And then your final step, step 6, is to combine the 2 half reactions back into one giant balanced overall redox reaction. And so our oxidation half reaction, the 8 hydroxide plus the 4 hydrogen peroxide forms 4O2 plus 8 H2O plus 8 electrons lost. And then our reduction half reaction, we're gaining 8 electrons. As the reaction proceeds, Cl2O7 forms 2 ClO2 minus plus 6OH minus, giving us for our overall balanced redox reaction. Again, let's go back and cancel out those electrons. They don't need to be expressed in the final reaction. We can get rid of some of our hydroxides here, end up with 2. The waters will cancel out all of them here and leave us with 5 over here, which means that our final balanced redox reaction is going to look something like this: 2OH minus plus 4 waters plus Cl2O7 forms 4O2 plus 5 H2O plus 2 ClO2 minus. Just kidding, that's an H2O2. And we're done.